谢，谢谢。
Please tell me you speak English. I'm Detective Carter. Do you speak any English? Do you understand the words that are coming out of my mouth?
Hey guys. That was a little clip from one of my all-time favorite movies, Rush Hour 1, where Chris Tucker is picking up Jackie Chan's character from the and just the beginning of their crazy adventure. One of my absolute all-time favorite movies. Me and my brother quote it as much as we humanly can. But okay, so today, day 6, reviewing for our final here. Today we're going to be looking at word problems. So I'm just going to go through most of these with you here, just so you kind of know what you're doing on the homework. It's going to be very similar, okay? So let's get started here. So example 1. The product of two consecutive odd natural numbers is 323. Write an equation and solve. So, okay. So product here, right, means to multiply. Two consecutive odd natural numbers. There's the confusing part, I think, right here. But we can break this down. So odd numbers, we know what those are. So like 1 is an odd number, 3, 5, and 7. Excuse me. Now these also happen to be consecutive, right? There's no odd numbers in between 1 and 3, 3 and 5, 5 and 7, and so on. So I'm going to call one of these numbers x. Now the other number has to be x plus 2, because you'll notice here, to go from 1 to 3, you add 2, 3 to 5, add 2, 5 to 7, you have to add 2 every time. So if I have one odd number, I have to add 2 to get to the next one. Okay, so product, right, means to multiply, so I'm just going to multiply these. X times x plus 2 has to equal 323. And so now to solve, right, I'm going to go ahead and distribute the x. I get x squared plus 2x equals 323. I'm going to subtract the 323 over to the left-hand side. So I get x squared plus 2x minus 323 equals 0. And now this just becomes a good old-fashioned diamond problem. So negative 323 on top, 2 on the bottom. Now, this is the hard part. Figuring out two numbers that multiply to 323 and add up to 2. So this is the tough part, but I'll save you the trouble this time. It's going to be 19 and negative 17. So this is going to be x plus 19. X minus 17 equals 0. Take each of these, go ahead and solve. You get negative 19 and positive 17 for our two answers for x. Now, the last part of this question is this term right here in the middle, natural numbers. Natural numbers are positive integers. So 1, 2, 3, 4, 5, 6, 7, and so on. So negative 19 is out. And then so what are my two numbers? Well, if 17 is x, add 2 to that, I get 19. And there's my two consecutive odd numbers that multiply to 323. Okay? Good. Let's take a look at the next one. Find the missing length as a simplified radical. So you have a right triangle here with legs 7 and 17. I'm going to call this missing side x. And hopefully by now we all remember that Pythagorean theorem is the way to go here, right? So the sum of my two legs squared, so 7 squared plus 17 squared, is going to equal my missing side x squared. So 7 squared, 49. 17 squared, 289, equals x squared. Go ahead and add up both of those. You get 338 equals x squared. I'll give you guys a second to catch up. Now, solve for x. We want to take the square root of both sides because it's x squared, so it'll get rid of that square. Now, square root of 338. Factor tree for this one's kind of tough here, right? But you can try some different numbers out. I'm going to go 169 and 2. Now 169 I know is 13 times 13. So that's going to work out pretty nicely here. So x is going to be 13 root 2 feet. Do not forget units if you're given units. Okay, so just a basic Pythagorean theorem problem, kind of like we saw in the last chapter there. So hopefully nothing new. Factor trees, all that fun stuff. Okay, so 13 root 2 feet for that one. Let's keep moving along. We're doing pretty well here. Example 3. The formula. A equals P parentheses 1 plus R to the T power. So I'm going to rewrite that over here. A equals P parentheses 1 plus R to the T power can be used to compute the total amount of money A that accumulates when the principal P is invested at a yearly interest rate R and left to compound for T years. Calculate A for an investment of $4,000 at 3.95% for 7 years. Please round. Okay, so a lot going on here, but these interest rate problems can be broken down pretty easily if we just go variable by variable. So this A, right? Total amount of money A that accumulates. That's why we use A there for accumulate. But that's what we're solving for. We're going to find out how much money we get after investing and getting interest on it. Okay? So, the principal P. Let me see if I can use some different colors here. The principal P is invested. That's what I'm starting out with, right? An investment of $4,000. That's going to be my P. So 4,000 is going to go right there. Invested at a yearly interest rate R of 3.95%. That's my only rate there. So I'm going to plug that in. 1 plus. Now, here's where you got to be careful. Because a percent is not the exact same as a decimal. If you have 3.95%, you need to put that in as 0.0395 as a decimal. So in other words, move the decimal point 2 places to the left to go percent to decimal. And now the last thing here is how long are we investing for? T years is going to be 7 years. And now you can literally type this into the calculator in this order. Or, if you want to take your time while doing this, right, one thing you can do is go by your order of operations. Do the parentheses first, right? 1 plus 0.0395 is just 1.0395 to the 7th. Then, next in your calculator, do the exponent, and then multiply it by 4,000. Okay? So either way you go, you should still get $5,246.04. Now this is the last piece we kind of brushed over. Round your answer to 2 decimal places. Well, money is always counted to cents, which is 2 decimal places. So $5,246 is what we end up with after 7 years. So after 7 years, you get about $1,200. Not bad, not bad. Wouldn't mind having that kind of money right now. Okay. We're gonna, well, let's see. I don't have my calculator, but all right. Well, let's look at example 4 anyways here. I don't have my calculator, but you guys can probably figure out the answer on your own here. But let's see. Find the time it takes for $2,000 to grow to $6,000 if it is compounded continuously at 4%. So this is a little bit different type of problem here. First of all, we're solving for t time, right? And we have a different kind of interest, continuous interest, which we're going to get into once we finish up all this final review stuff. But the problem works out the same way. Whenever they give you a formula, you just have to find all your different variables within the problem. Okay, so the first variable we have there is our rate, R, down there, and that's 4%, right? Let's see, natural log, well, we know that. We've worked with natural, actually, we haven't worked with natural log, have we? Okay, I'll come back to this ln thing here in a second. But P is the principal, right? I'm going to invest 2,000. And my end goal is to turn it into 6,000. So I'm just going to follow along with the formula here, and let's see. So T is going to equal 1 divided by R. So once again, 4% is 0.04 times ln, natural log, and like I said, I'll explain this in a second, natural log of A divided by P. So I want to have 6,000, but first I have to invest 2,000. And now this is something you can literally, once again, type in onto the calculator. Now if you have one of our calculators, the 83s, ln here is the natural log, which, like I said, we're going to get into more of this stuff after the Harper final review stuff. But this is natural log, and all this is a log with a particular base. I'm not going to delve into that now, but on the calculator, the ln button should be, I believe, right above the log button or very close by. Okay, so the ln button is very close to the actual log button, and you would just type in 6,000 divided by 2,000 once the parentheses pops up. Okay, so that's how you set that one up. Once again, key thing, just making sure you're looking for those variables, within the problem, because they're going to give them to you. Okay? All right, that one was a bit weird. So let's go ahead and actually let's take a quick break. Wow. Good God. These are beautiful. Absolutely nothing. Say it again. Cool. Another one of my favorite scenes from that movie, which I just realized was probably a little bit inappropriate, but we'll keep that our secret. Okay. I really do love that movie, though. I think you guys were like 3 when it came out, but you guys should all go check it out. It's great. All right. So let's go ahead and flip over here, and we can wrap this up with the last couple of examples. All right. So example 5. Write a system of equations to answer the following using n for the number of nickels and p for the number of pennies. So before I do anything, I'm just going to write that. N equals nickels. P is going to equal pennies. Do not solve the system. Okay, so a little bit easier for you guys. We're just going to set this one up. Now, a boy has 45 coins that are all nickels and pennies. So you have 45 total coins made up of nickels and pennies. So let's make an equation with that. N plus P, because they're together, right, has to equal 45. We have 45 coins. So we've used that sentence. And now the second sentence here, he has 201 cents altogether. So this is looking at the actual, dollar amounts here, right? But now this is a little bit tricky. 201 cents. I know that's $2.01, but we're going to think of this just in terms of cent here. So a nickel is worth 5 cents. Whoops. There we go. A nickel is worth 5 cents, so we have 5 times every nickel we have, plus a penny is worth 1 cent, so 1 cent for every penny we have, and together we get 201 cents. And now, here is my system of equations I can go substitution, elimination, graphing, however I want. Okay, but hopefully the setup here makes sense. And really all we did was, and actually I should probably highlight these, I wonder if I can, right? We used the first sentence here, 45 coins that are all nickels and pennies. That got us that equation. And then, is there a black highlight? And how many nickels and, oh God, I'm an idiot. 201 cents altogether gets us the other equation, 5n plus 1p equals 201. I just realized these are Michigan colors, and I feel disgusted with myself. But yeah, that's really it for that one. Okay, last two here. The sum of two numbers is 51. So I have two numbers, x and y. Sum means to add, and I get 51. The difference is negative 17. Actually, before I get that, let me try this thing again here. So the sum of two numbers is 51. So that right there gets me that equation. Let's go with Illinois orange here. The difference is negative 17. So x minus y is negative 17. So that's where I get that equation from. Okay? Now I'm just going to rewrite these so the highlighter isn't in the way. Write a system of equations, check, and solve it to find the two numbers. So once again, here's my system. I can graph, I can substitute, I can eliminate. I always prefer elimination. I don't know if you guys remember us doing this, right? But you can circle what you're going to eliminate. Now here my y's, one is a positive one is a negative one, so those are primed for elimination. I'm going to add my two equations together. X plus x is 2x. Y plus a negative y is 0, so I don't have to write it. And 51 minus 17 is 34. Divide both equations by 2. Divide both sides of the equation by 2. And x is 17. I'm going to take this value and I'm going to plug it into my first equation. I could plug it into my second equation. I'm just choosing not to. 17 plus y equals 51. Subtract 17 from both sides. Those cancel out. And y equals 34. And there you have it. Two numbers that add up to 51, but subtracted, negative 17. Okay, nicely done so far. Last one here, example 7. Okay, this one's kind of a weird problem. The velocity, so right there I'm going to stop. Velocity is just another way to say speed. Okay, so the speed of some object in meters per second, that's a unit, right? Meters per second, that's what our answer is going to be in, can be found after it has fallen h meters using the formula v equals the square root of 19.6 h. So this formula I'm going to come back to. Find the velocity of a stone that has fallen 41 meters after being dropped from a cliff. Round your answer to one decimal place. Include units on your answer. Okay, so we're looking for velocity. We're looking for the speed after it is dropped. So once again, look through the problem, right? What can I find? After it is dropped h meters. It's fallen 41 meters. So that's my h. That's going to be the h in my formula. Right, so I'm going to rewrite the formula here. V equals the square root of 19.6. And now my h, my height, is 41 meters. Plug it in. You can run this through your calculator, right? Square root of 19.6 times 41. Now remember, I use parentheses here just as a reminder. Whenever you plug in a number for a variable, always use parentheses. And I think you should get something like 28.3 meters per second. Okay, it told us in the beginning velocity is in meters per second, so that's my units. And that's really it. Just a bunch of different types of word problems here for us to take a look at. Hopefully you guys are good. Hopefully this was easy to follow along. Any questions, please bother Mr. G. Just kidding, you're never a bother. Unless your first hour, unless your name is Kenny. Just kidding. Love you, kid. Or in fifth hour, unless your name is Melanie. Just kidding. Keep up the good work. By the way, Mr. G, feel free to check both of their note sheets and report back to me tomorrow. Thanks. Gotta go. Bye.